An algebraic expression containing two terms is called binomial. When a binomial is multiplied by itself a number of times, then the result is called the product or expansion of the binomial. This can be shown as follows. From this expansion, the following characteristics can be observed. First, the number of terms in the expansion is 1 more than the exponent for which the binomial is raised. So if the exponent is 0, that means there's only one term. And remember, any number or value raised to 0 is 1. If the exponent is 1, then there are two terms. If 3 is the exponent, the number of terms is 4. If the exponent is 6, then there are 7 terms. 1, 2, 3, 4, 5, 6, 7 terms. So the number of terms in the expansion is 1 more than the exponent for which the binomial is raised. Another characteristic is the degree of each term in the expansion is equal to the exponent of the binomial. In each term, the degree is equal to the exponent for which the binomial is raised. For example, when the exponent is 1, the degree of each term is also 1. Pag walang nakalagay na number, that means it is 1. When the binomial is raised to 2, the degree of each term is also equal to 2. First term, the degree is 2. In the second term, if we add the exponent of a and b, that will be equal to 2. And the third term also has a degree of 2. Similarly, if the exponent of the binomial is 6, the degree of each term is also equal to 6. First term, 6. Second term, add the exponent of a and b, which is 5 and 1 respectively, and that is equal to 6. Third term, add 4 and 2, and that is also equal to 6. Fourth term, add 3 and 3, that is 6. Fifth term, also add 2 and 4, which is also equal to 6. Sixth term, 1 plus 5 is 6. The seventh and final term, the degree is also equal to 6. Another characteristic, the first term of the expansion a has an exponent for which the binomial is raised. So kung ano ang exponent ng binomial, ganun din ang exponent ng first term sa expansion. Then, the exponents of the expansion start with the power for which the binomial is raised and gradually decreases as the second term of the binomial increases its power until it reaches the exponent for which the binomial is raised. In this binomial, the first term is a and the second term is b. The exponent of the first term gradually decreases. For example, when the exponent of the binomial is 2, the exponent of the first term is also 2, then it becomes 1. When the exponent is 3, the exponent decreases from 3 to 1. If it is 4, we have 4, 3, 2, 1. If 5, it also decreases to 4, 3, 2, 1. Similarly, if the binomial is raised to 6, the power of the first term a gradually decreases from 6 to 5, 4, 3, 2, 1. If the first term a gradually decreases, the second term b of the binomial increases its power until it reaches the exponent for which the binomial is raised. b starts to appear in the second term of every expansion and gradually increases its power up to the exponent for which the binomial is raised. So if the exponent is 2, we have 1 and 2. If 3, the power of b starts at 1 to 2, then 3. If it is 4, we have 1, 2, 3, then 4. If 5, it starts at 1 and also ends at 5. If the binomial is raised to 6, the second term b increases its power from 1, 2, 3, 4, 5, and finally 6, which is the exponent for which the binomial is raised. So that is one characteristic of the expansion. And the sum of the exponents of the terms of the expansion is equal to the power for which the binomial is raised. This is similar to the second characteristics of the expansion. Kung i-add natin ang exponents ng bawat term, it is equal to the exponent for which the binomial is raised. For example, 1 plus 1 equals 2, 2 plus 1 equals 3, 2 plus 2 equals 4, 2 plus 3 equals 5, 2 plus 4 equals 6, and so on. So these are the characteristics when the binomial a plus b is raised to a number n. From the expansion of the binomial, another pattern can be observed formed by the numerical coefficients which is shown in a triangular array. If only the coefficients are written, they will appear in this manner. We have 1, then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and so on. This array of numbers is called the Pascal's triangle, named after Blaise Pascal. The array can be continued observing the same pattern, such as the three lines can be formed as the following. Observe that each new row of the Pascal's triangle is formed by adding the elements of the previous row in pairs. Each row starts and ends at 1. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, and 5 plus 1 is 6. That is why the numerical coefficients of the binomial a plus b raised to 7 are the following. 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is also 35, 15 plus 6 is 21, and 6 plus 1 is 7. The same pattern is applied to the succeeding array. Examples. Number 1. Use the Pascal's triangle to expand x plus y raised to 7. In this problem, our first term is x, while the second term of the binomial is y. The first term of the expansion is followed by the term with x having the exponent 6 or 1 less than the exponent of the first term. At the same time, y will start to appear with exponent in ascending order as x appears in descending order. Note that the sum of the exponents of x and y should be equal to the exponent for which the binomial is raised. It is shown as follows. Remember the characteristics of the expansion. The first term starts with the power for which the binomial is raised. So we have x raised to 7 and then gradually decreases its power. At the same time, the second term y will start to appear with exponent in ascending order until it reaches the exponent for which the binomial is raised. Now, to determine the coefficients of the variables, the Pascal's triangle can be used. Since the binomial is raised to the power of 7, we use the row in the triangle where the second entry is 7. So we use these values. The coefficients are 1, 7, 21, 35, 35, 21, 7, and 1. If we put the two together, we have x raised to 7. 1 times x raised to 7 is x raised to 7, plus 7x raised to 6 times y, plus 21x raised to 5 times y squared, plus 35x raised to 4 times y cubed, plus 35x cubed times y raised to 4, plus 21x squared times y raised to 5, plus 7x times y raised to 6, plus 1 times y raised to 7, or simply y raised to 7. And this is the expansion of the binomial x plus y raised to 7. Another example. Expand p minus q raised to 5. The binomial can be written as the quantity p plus negative q raised to 5. We can write the expansion based on this expression. However, take note that a is p while b is negative q. So p plus negative q quantity raised to 5 is equal to a raised to 5 or p raised to 5, since we let a be equal to p, plus 5a raised to 4, which is 5p raised to 4, times b, which is negative q, plus 10a raised to 3, which is 10p raised to 3, times b squared, which is negative q raised to 2, plus 10a squared or 10p squared, times b raised to 3, which is negative q raised to 3, plus 5a or 5p times b raised to 4 or negative q raised to 4, plus b raised to 5, which is negative q raised to 5. Positive 5b raised to 4 times negative q is equal to negative 5b raised to 4 times q. The quantity negative q squared is equal to positive q squared times positive 10p cubed is positive 10p cubed times q squared. The quantity negative q raised to 3 is negative q raised to 3 times positive 10p squared is negative 10p squared times q raised to 3. The quantity negative q raised to 4 is positive q raised to 4 times positive 5p is positive 5p times q raised to 4. Then the quantity negative q raised to 5 is equal to negative q raised to 5. And this is the expansion of p minus q raised to 5. Another example. Expand 3x minus 2y raised to 4. We're gonna expand this binomial with exponent 4 based on this expansion. But take note that a is equal to 3x while b is equal to negative 2y. So this is equal to a raised to 4, where a is equal to 3x, plus 4a raised to 3 times b, which is equal to 4 times 3x raised to 3 times negative 2y, plus 6a squared times b squared, or 6 times 3x squared times negative 2y squared, plus 4a times b raised to 3, or 4 times 3x times negative 2y raised to 3, plus b raised to 4, or negative 2y raised to 4. Evaluate. The quantity 3x raised to 4 is equal to 81x raised to 4. 3 raised to 4 is 81 times x raised to 4, plus 4 times 27x raised to 3 times negative 2y. The quantity 3x raised to 3 is equal to 27x raised to 3. 3 raised to 3 is 27, plus 6 times 9x squared times 4y squared. The quantity 3x squared is 9x squared, while the quantity negative 2y squared is equal to positive 4y raised to 2, plus 4 times 3x times negative 8y raised to 3. The quantity negative 2y cubed is equal to negative 8y raised to 3, plus the quantity negative 2y raised to 4, which is equal to positive 16y raised to 4. Simplify, we have 81x raised to 4, positive 4 times 27 is 108, times negative 2 is negative 216. Then copy x raised to 3 and y. 6 times 9 is 54, times 4 is positive 216. Copy x squared and y squared. 4 times 3 is 12, times negative 8 is negative 96. Copy x and y cube, plus just copy 16y raised to 4. And this is the expansion of this binomial.